Hello and welcome back to you in the new lesson. This is Lakshmikant Tiwari. In this tutorial, we will learn about the AVR microcontroller, ATmega32 architectures and the programming instructions. The AVR microcontroller is a family of the RISC microcontroller from the Atmel Corporation. There are two types of the architectures, the RISC architecture and the CISC architecture. The RISC architectures, that means the reduced instruction set of the computer, and the CISC is the complex instruction set computer. RISC architectures have an advantage over the CISC, such as RISC architecture have a less set of the instruction set. At ATmega32 microcontroller have only 131 instruction sets, and also it has a large set of the registers. ATmega32 have 32 register sets, and each register sets are the 8-bit long. And also the RISC architecture is a load store type of the architectures. Okay, and also the RISC architectures, most of the instructions are only the single clock cycle. About nearly the 95% instructions are one clock cycle instructions, and other 5% of instructions are nearly 2 clock cycles, and the very few instruction sets which takes a 3 clock cycle of the executions. And the lots of many more other advantage have over the CISC, this RISC architectures. There are mainly the three sub-series of the AVR microcontroller, that is the ATmega series, the XMega series, and the ATtiny series of the microcontroller. Throughout this tutorial series, we will be discussing about the ATmega32 microcontrollers. The ATmega32 microcontroller have a 40 pin. As you can see here, it has a 4 port, port A, port B, port C, and the port D, and each port have an alternate function. Port A have an alternate function such as ADC. The port B have an alternate function timer 0, timer 1, internal clock, the external clock, and the analog input 0, analog input 1, and this is for the SPI communication. And the port C have a T oscillation 2, T oscillation 1, and the TDI, TDO, TMS, and the T clock for the JTAG, and this one is for the I2C communication. And the port D is multiplexed with the UART, receive and the transmitted pin, and the external interrupt 0 and the external interrupt 1. Now output compare match 1B and the 1A. Okay, and this is the reset pin. This is known as the active low reset pin, and this is the VCC. As usual, this microcontroller is a CMOS 8-bit microcontroller, is running at the plus 5 volt VCC, and at the ground, this is the digital ground, and here this is analog reference, analog grounds, and analog VCC is corresponding to this analog block for the ADC. While you are not using the ADC block, then at that time you have to also connect this analog VCC and analog ground for at a particular level. Okay, so this microcontroller have a 32 GPIO, that is general purpose input output. As you can see here, the 4 port, and each port consists of the 8 pins, and the most of instructions are a single clock cycle instructions, about nearly the 95% of instructions. Okay, and also it has a total 131 powerful instructions. Okay, and the 32 general purpose working registers from the R0 to the R31 registers, and all those registers, each registers are 8-bit long registers, and there is also the on-chip 2-cycle multiplier that makes it very useful in the arithmetic computations. And as a visible with the name ATmega32, the 32 is corresponding to the 32 KB flash memory. Okay, so the last 2 digit is corresponding to the flash memory. ATmega16 have a 16 KB flash memory, ATmega8 have a 8 KB flash memory. Okay, and there is also the 1 KB EEPROM. The EEPROM is used for storing the constant data, and the 2 KB internal SRAM is also there. Okay, and if we discuss about the peripheral features, it has two 8-bit timer counters and one 16-bit timer counters, and there is also the real-time counter with the separate oscillators, and there is also the scheme for the waveform generations, that is the 4 PWM channels. As we have already discussed, the port A is multiplexed with the ADC. It has a 8 channel 10-bit ADC, and in those 8 channel ADC there are two differential channel with the programmable gain, and the gain can be the 1x, 10x and the 200x. And there is also the on-chip SPI, the JTAG, UART, and all these this UART, JTAG, SPI, I2C, these are the serial communication protocols. There are some special features which have ATmega32 microcontroller, and those features are the power on reset and the programmable brownout detection. The power on reset, that means that when microcontroller is power up, the microcontroller will go automatically on the reset mode. Okay, that is known as a power on reset. And the programmable brownout detection means microcontroller will stop functioning when power supply will go below the a threshold level, such as a 2.7 volt or a 4.5 volts, depends on the ATmega 32L or ATmega 32 series. Okay, so and also this ATmega series uh, have uh, have a lots of oscillator uh, oscillator options, such as internal oscillators or external oscillators. Okay, in the internal oscillators we can use maximum 8 megahertz internal oscillator. In the external oscillator we can use up to the 16 megahertz external oscillator, that is the crystal oscillator, if we talking about the ATmega 32. But ATmega 32L only supports the 8 megahertz maximum speed. There is also the 6 sleep mode, and these sleep modes are very helpful in the power saving. Okay, and those modes are the idle modes, okay, in which everything will stop, okay, even the clock, and only at a very low clock the CPU will run, only the CPU. And there is also the ADC noise reduction mode, in which only ADC will work and other peripheral will be stopped. And there is also the power save mode and the power down mode, and one is the standby mode and another is the extended standby mode. Okay, I am stopping this tutorial here. Thank you so much for watching, and if you have a question, please comment below.